Approximating values of a function using local linearity and linearization. Oh, that's a hard word for me to pronounce being Danish. So this is when you can hear I'm a real foreigner. All right. So depending on what class you're in, we might have had time to do the group work for this. If not, then I want you to try this on your own. It's an exploration. So the key is that you give it a shot. That's all I'm asking. If you haven't done it with a group yet, then stop the video right now, pause it, and give the explore with your group mates a shot all the way down to question number 9. Okay. You can always backtrack and watch the video afterwards, but you got to try on your own. Approximate the cube root of 68 without using a calculator. What two perfect cubes is 68 in between? All right, so I know that 68, oh, I have to be able to draw. 68 is, the one perfect cube is 64. So the cube root of 64 is 4, and the next one up is 125. And the cube root of 125 is 5. So I know that the cube root of 68 is somewhere between, somewhere between the cube root of 64 and 125. That is somewhere between 4 and 5. Now, the cube root of 68 is way closer, because 68 is way closer to 64 than it is to 125. So my reasonable one is going to be 4.1. If you did 4.2, whatever, but definitely pick a value closer to 4 than to 5. Write an equation for the tangent line at x is equal to 64, the perfect cube closest to 68. That's why I'm picking that one. For the function f of x is equal to the cube root. So we're taking the cube root of something here. Okay, so let's see here. I'm going to take f prime of x, which is going to be 1/3 x to the negative 2/3, or it might help to write it as a fraction here, so x squared. I need to find that f prime at 64, and I also need to find f at 64. F of 64 is 4. You're just taking the cube root of 64. F prime is 1/3 cube root of 64 squared. You can do that in any order. So the cube root of 64 is 4, squared is 16. So 1/3 times 16, which is 1/48. Okay, I'm going to put it in point slope form, which is the next part here. Solve the equation. Oh, no, we're still on it. So y minus 4 is equal to 1/48 x minus 64. So right now, that's the tangent line. Do not put it in slope-intercept. You guys, some of you are all so attached to slope-intercept form. Do not do that. In calculus, it is the least useful form most of the time. So in this particular case here, we are going to do the tangent line, and I drew that in here in the figure on the right-hand side. So what this means is that I have the tangent line here at 64. The next step is asking you to solve for y. So without putting it in slope-intercept form, do not distribute. You don't want fractions and messiness. You're just going to leave it like this. Eventually, we're going to be substituting in 68. So it's easier to substitute in the 68 and take 68 minus 64 and get a 4 and multiply by 1/48 than having the 1/48 distributed, and then you get fractions in both parts and have to substitute. It makes it harder for yourself. Trust me on this one. All right. So now in number 4, it says use the equation in question 3 to approximate the value for the square root of 68. In other words, find the y value when x is 68. So we are essentially finding y when x is 68. So 1/48 times 68 minus 64 plus 4, which is equal to 1/48 times 4 plus 4, which is equal to 1/12 plus 4. All right, so I'm going to, it's going to be, okay, 4 and 1/12. But I think it would be easier if I looked at it as a decimal, because that would be easier to see how close my estimate is here and how good it is. So I'm just going to take one, if I'm doing this totally without a calculator, I'm taking 1 and dividing by 12. So it doesn't go into 1. Carry down the 1 and a 0. It doesn't go into, it doesn't go into 10. So carry down, so that's a 0. Carry down the 1 and another 0. It goes into 100 8 times. So that is 8 times. That's going to give me a 96. 4, carry down another 0. 12 goes into 40 3 times. And that's going to, I can see that starts repeating, because that's going to be a 36, 4, okay, 3 repeating. If I'm doing 3 decimal places, all right, it would round to 0.083. So that's going to be 4 plus 0.083, which is 4.083. All righty. Why do you think using the tangent line works as a reasonable approximation? The tangent line at x is equal to 64 is very close to the function of f of x when x is equal to 68. The values for f of x are at x is equal to 64 and x is equal to 68. Well, no, I should say at x is equal to, okay. Come on. X is equal to 68 is very close to the value of the tangent line at x is equal to 68. 68. So here, if I look at the graph right here, I can see, here at 68, which is like right around there maybe, right? They're so close together, I can barely see the difference between the function itself and the tangent line. Obviously, if I zoomed in very close, you could see they would start separating more and more, but it's like a minuscule difference between the two of them. So therefore, a tangent line would be pretty representative, or a pretty good close estimate of the cube root of 68 there, that tangent line there. Now, it wouldn't be if I then asked you to use this tangent line to estimate at x is equal to 10, that would not be a good choice. You would have to pick a tangent line of the function that's much closer to the 10 there. So I would probably, the perfect cube that would be closest to 10 would be 8. So then we would use the tangent line over here instead, like that. Okay. Is your estimate you found in question 4 an over or an underestimate? The estimate found is an overestimate, since the function f of x is equal to the cube root of x is concave down at x is equal to 64. Concave down just means it curves down. So the function will looks like this. It curves downwards. And then if I draw in the tangent line here, I'm trying to make it a little more explicit so you can see it. So the tangent line is here. right here. So the entire tangent line is above the actual function at all of the points except at 64. So that means if I'm using this point right here to estimate for that point there, my value that I actually found is slightly bigger than the actual value, right? So here, I'm going to add to that the tangent line is above the actual function at x is equal to 64 for all values other than x is equal to 64. Because at 64, it's on it, right? All right. Use your calculator now to find an estimate for it. So what did we get up there? We got a 4.083. Let's see how close we are. So I'm going to take the cube root in a calculator. We're taking 68, cube root of that. And the cube root, we got, whoops, that's not, here, the cube root of 68 on the calculator is approximately 4.0816, blah, 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 17, really. Oh, so we are really, really close, if you see that. So that's a pretty strong estimate, 17 like that. And our estimate was 0.083, so we're only off by 0.0013, really. All right, can you use the same tangent line to estimate the square root of 7? 70, not 70, 7? Yes, you can, because 70 is still relatively close to the 64 compared to the 125. So yes, since cube root of 70 is relatively close to the cube root of 64, the tangent line at x is equal to 64 is still close to f of x at x is equal to 70. Whereas in number 9, it's saying, would it be useful to use it at 120? You could use it, but it would be better to use 125. So it should be centered. So in this case, it wouldn't be a good estimate. So I would say no here. Technically, you can substitute in any value, but you want to pick the one that's the best value. The tangent line should be centered at x is equal to 125 instead, since 120 is closer to 125 than 64. And so those are the perfect cubes that we're going to use.